can't do that in a garage. There's just a few places in the world with the right equipment and only a few people in the world with the right training to be able to do that.
They said it couldn't be done, that separating one of the world's most complex hypercars outside a factory environment was simply impossible, but that only made the challenge more irresistible. When Mate Rimac explained that only a handful of specialists in specially equipped facilities could split a Bugatti Chiron in half, it sounded like a final verdict, a line drawn between ambition and reality. Yet in a modest workshop, without factory tools, proprietary training, or access to official parts, Matt Armstrong stood in front of a wrecked machine worth millions, determined to prove that ingenuity could rival exclusivity. The car itself, a severely damaged Bugatti Chiron Pur Sport, represented not just a mechanical challenge, but a philosophical one. Could knowledge, patience, and persistence dismantle something designed to resist exactly that? Bolt by bolt, panel by panel, the process began to unfold like a high-stakes surgical procedure, revealing a structure built from carbon fiber, titanium, and engineering precision rarely seen outside aerospace. As body panels came away, the complexity became clearer. Coolant lines stretching the length of the chassis, hydraulic systems intertwined with electronic looms, and structural bolts designed to hold together a machine capable of over 1,500 horsepower. Every step forward raised attention, because one mistake could mean irreversible damage, and there would be no call to the manufacturer for help. The workshop became a stage for calculated risk, where improvised tools replaced factory jigs and bin wheels stood in for specialized lifting rigs. Slowly, almost unbelievably, the impossible began to happen. The front monocoque separated from the rear powertrain, exposing the massive W16 engine like a mechanical heart removed from its body. It was a moment that transformed skepticism into proof, demonstrating that even the most exclusive engineering could be understood and dismantled by determined hands. Yet the victory was only partial, because the true damage lay hidden. Cracked cast aluminum mounts supporting the entire drivetrain, broken under the force of the crash. The discovery turned triumph into urgency, forcing the team to push further, removing the gearbox, draining rare fluids, and carefully dismantling components never intended to be serviced outside official channels. Each removed part told a story about the violence of the impact and the resilience of the design, while also reinforcing the central idea driving the project. If a human built it, another human could repair it. The workshop atmosphere shifted from disbelief to confidence as the final broken pieces were laid out, physical evidence that the impossible barrier had already been crossed. What began as defiance of a statement evolved into something larger, a testament to curiosity, problem-solving, and a refusal to accept limitations imposed by exclusivity. And as a stripped-down hypercar stood divided yet conquerable, the narrative became clear. This wasn't just about fixing a $6 million machine. It was about challenging the notion that innovation belongs only to those with the biggest budgets, proving instead that determination, creativity, and relentless effort can rewrite the rules, even when the world's most prestigious automaker says it can't be done. They said the task belonged only to elite facilities, guided by proprietary tools and factory-trained engineers. But the moment the damaged Bugatti Chiron Pur Sport rolled into a small independent workshop, the narrative began to change. The warning from Mate Rimac echoed loudly. Separating a Chiron outside of specialized centers simply wasn't possible. Yet for Matt Armstrong, that statement didn't sound like a limitation. It sounded like a challenge. The car itself, once a symbol of perfection, now sat wounded, its carbon fiber panel cracked, its structural mounts compromised, and its drivetrain potentially beyond saving. But what unfolded next was less about repair and more about rewriting assumptions. Every removed bolt became an act of defiance. Every disconnected coolant line a step deeper into territory that few mechanics had ever seen. The engineering of the Chiron revealed itself layer by layer. Titanium fasteners, intricate hydraulic systems, and wiring looms running like veins through a carbon monocoque. It was complexity designed to intimidate, yet the more it was exposed, the more approachable it seemed. Improvised tools replaced factory equipment, determination replaced formal certification, and patience replaced procedure manuals. When the front half of the car finally separated from the rear, balanced on makeshift supports rather than million-dollar rigs, the impossible transformed into reality. The massive W16 engine hung exposed, a reminder of the stakes involved and the scale of what had just been achieved. But the victory was only the beginning. Beneath the triumph lay the true damage, cracked aluminum engine mounts and structural components shattered by the force of impact. The team pressed forward, removing the gearbox, draining fluids, and dismantling parts never intended to be serviced outside official channels. Each step demanded careful judgment, because without factory support, every decision carried risk. Yet the deeper they went, the clearer the message became. Exclusivity does not equal invincibility. The stripped chassis, separated powertrain, and laid-out components formed a visual statement, proof that even one of the most advanced hypercars ever built could be understood by those willing to learn. What started as skepticism evolved into confidence, and confidence into momentum. The workshop transformed into a battlefield of ingenuity, where creativity replaced convention and persistence overcame doubt. By the time the broken castings were removed and the path toward repair emerged, the narrative had shifted completely. This was no longer just a rebuild. It was a demonstration of human curiosity pushing against manufactured limits. The challenge now extended beyond disassembly into reconstruction, where 3D scanning, custom fabrication, and reverse engineering would play crucial roles. And as a divided hypercar stood ready for its next phase, one truth resonated louder than ever. The impossible is often just a word waiting for someone determined enough to prove it wrong. The deeper the rebuild progressed, the more the project evolved from a daring teardown into a test of precision engineering under pressure. With the hypercar now split apart, the exposed components told a story about destruction and resilience. The carbon monocoque, though scarred, still demonstrated remarkable structural integrity, a testament to the philosophy behind the Bugatti Chiron. Build something that can survive extreme forces without compromising the driver's safety. Yet surrounding that core were fractured mounts, bent brackets, and intricate systems that required not just replacement but careful reinterpretation. Without factory schematics, every measurement had to be reverse-engineered, every alignment double-checked. The workshop floor filled with labeled bolts, sensors, and brackets, each piece catalogued like evidence in a high-stakes investigation. What made the challenge even more dramatic was the rarity of the component involved. Replacement parts for Chiron are not items that can be ordered overnight. Many are produced in extremely limited quantities and tied to strict distribution controls. This forced a team to consider unconventional solutions, repairing rather than replacing, fabricating rather than sourcing. The cracked castings became the focal point, requiring advanced welding techniques and precision machining. Any misalignment could compromise the drivetrain, which delivers enormous power through an equally complex transmission system. The process slowed, not because of uncertainty, but because the stakes demanded patience. Every step forward represented hours of measuring, planning, and verifying that as the reconstruction phase began, optimism started to replace tension. The repaired mounts were reintroduced, the massive W16 engine prepared for reinstallation, and the once chaotic workspace transformed into a carefully orchestrated assembly line. Watching the drivetrain slowly return to the chassis created a sense of reversal, like time itself moving backward, undoing the damage piece by piece. Yet the emotional weight of the project remained, because the goal was not just to rebuild a machine, but to prove that knowledge and determination could rival exclusivity. The narrative had shifted from can it be separated to can it be brought back to life. The reassembly also revealed just how interconnected every system inside the hypercar truly is. Cooling lines had to be routed with millimeter precision, electronic modules reconnected in the correct sequence, and structural bolts torqued to exact specifications. Unlike ordinary vehicles, even minor deviation could affect performance at extreme speeds. The process demanded calm focus, with each completed section building confidence for the next. Slowly, the divided hull became one again, the chassis regaining its form, the powertrain reconnecting to the carbon core. By the time the wheels were ready to touch the ground again, the journey had become something larger than mechanical restoration. It symbolized the idea that boundaries often exist only until someone tests them. The rebuilt hypercar stood not just as a repaired machine, but as a statement that curiosity, skill, and persistence can challenge even the most guarded engineering. And as the project moved toward its final stages, the anticipation grew. The first start, the first movement, the moment when silence would give way to the unmistakable roar of a revived legend, the moment of truth approached slowly, almost deliberately, as the rebuilt structure of the Bugatti Chiron Pur Sport began to resemble the masterpiece it once was. Panels that had been stacked in corners for weeks were now carefully reattached, each one aligning with microscopic precision. The carbon fiber bodywork, once fractured and uncertain, regained its flowing shape, reflecting light in a way that hinted at the machine's original elegance. Yet beneath that beauty remained an intricate puzzle, miles of wiring, sensitive sensors, and cooling systems that had to operate flawlessly together. The reassembly was not just mechanical, it was psychological. Each successful connection boosted confidence, but every unresolved detail reminded the team how fragile the victory still was. The workshop, once filled with disassembled parts, transformed into a quiet space of concentration, where even small sounds, the click of a connector, the tightening of a bolt, carried significance. Attention soon turned to the heart of the hypercar, the colossal W16 engine that defined the identity of the Bugatti Chiron. Carefully lowered back into position, it represented both the biggest risk and the greatest reward. The mounts that had been cracked were now restored, but the question lingered. Would they hold under pressure? Every measurement was reviewed, every torque value verified. Fluids were refilled, lines bled, and sensors calibrated. The process required patience bordering on obsession, because one overlooked detail could undo months of work. When the final connections were made, the car sat silently, fully assembled yet untested, a machine suspended between uncertainty and triumph. The first startup attempt carried an almost cinematic tension. Silence filled the workshop as power was introduced to the systems, electronics awakening one by one. Dash lights flickered, modules communicated, and the sound of fuel pumps priming hinted that life was returning. But even this stage demanded caution. Hypercars are unforgiving when systems are incomplete. With a deep breath, the ignition was triggered. For a brief moment, nothing happened, a pause long enough to amplify every doubt. Then, suddenly, the engine toned, the W16 firing into life with a deep mechanical roar that echoed through the room. The sound wasn't just noise, it was validation. Months of work, risk, and determination condensed into a single explosive moment of success. Yet the journey did not end with the engine running. The next challenge was movement, proving that the drivetrain, transmission, and suspension all functioned together. Slowly, the car was lowered onto its wheels, a symbolic return to normality. The first roll forward was cautious, almost hesitant, but it confirmed that the alignment held true. Every meter traveled increased confidence, transforming uncertainty into belief. The rebuilt hypercar, once declared impossible to repair outside factory conditions, now moved under its own power. The workshop erupted in relief, not just because the project succeeded, but because it redefined expectations. What began as skepticism toward a statement had evolved into a broader message. Engineering, no matter how advanced, remains a human creation, and human determination can match it. The restored machine stood as evidence that curiosity, skill, and patience can overcome barriers built by exclusivity. As the engine settled into a steady idle, the narrative reached its conclusion. The impossible had not only been attempted, it had been achieved. And in that moment, the rebuilt hypercar symbolized more than a repaired vehicle. It represented the enduring belief that limits exist only until someone decides to challenge them. As confidence grew, the rebuild entered its most delicate phase, fine-tuning the systems that transform raw power into controlled performance. The reassembled Bugatti Chiron Pur Sport was no longer just a collection of parts. It was a living mechanical ecosystem that required harmony between engine, transmission, aerodynamics, and electronics. Small adjustments to suspension geometry were made, ensuring that the chassis sat exactly as designed. Even a few millimeters of deviation could alter handling characteristics, especially in a machine engineered for extreme speeds. Alignment lasers replaced guesswork, and each wheel was carefully calibrated. The process demanded patience, because restoring appearance was only half the battle. Restoring performance was a true test. Attention then shifted to aerodynamic components, often overlooked but crucial to the identity of the Bugatti Chiron. The front splitter, rear diffuser, and carefully sculpted air channels were reinstalled with meticulous precision. These elements were not decorative. They managed airflow at speeds where physics becomes unforgiving. Each panel had to sit perfectly flush, ensuring that turbulence did not disrupt stability. The team understood that at high velocity, even minor imperfections could create unpredictable forces. The rebuild therefore became as much about airflow as mechanics, reinforcing the sophistication of the original design. With systems aligned and aerodynamics restored, the focus turned to electronics, the hidden brain of the hypercar. Modern vehicles rely heavily on software, and this one was no exception. Modules had to communicate seamlessly, sensors recalibrated, and error codes cleared. The dashboard lit up like a control center, cycling through diagnostics while technicians monitored readings. Slowly, warning lights disappeared, replaced by normal operating indicators. It was a quiet but powerful victory, proving that the digital side of the machine had survived the ordeal. The first controlled drive followed, cautious and deliberate. The rebuilt machine rolled forward, its suspension absorbing imperfections, its engine delivering smooth power. The feeling inside the workshop shifted from tension to disbelief. The impossible repair had become a functioning reality. Each meter driven confirmed structural integrity. Each gear change validated the transmission's restoration. The once damaged hypercar now behaved like the precision instrument it was designed to be. As the project neared completion, reflection became inevitable. What began as a challenge to statements from Mate Rimac had evolved into a demonstration of human capability. The rebuilt car stood not just as a repaired vehicle, but as a symbol of curiosity overcoming limitation. The journey showed that even the most exclusive engineering can be understood, dismantled, and revived by those willing to invest time and effort. And as the engine settled into a confident idle, the final message resonated clearly. The impossible often exists only until determination proves otherwise. The final stage of the journey carried a quiet intensity as a rebuilt Bugatti Chiron Pur Sport prepared to leave a controlled environment of the workshop and face real-world conditions. Up until this point, every test had been cautious, limited, and carefully monitored. Now, the objective shifted toward proving that the hypercar could perform not just mechanically, but dynamically, under motion, speed, and load. The engine note, once uncertain, now sounded confident, deep and steady. As the car rolled forward into open space, the sunlight reflecting off the restored carbon fiber bodywork felt symbolic, as if the machine itself had returned from a long silence. With the first extended drive, attention focused on feedback, vibrations, steering response, braking balance. The rebuilt Bugatti Chiron behaved with remarkable composure, its suspension absorbing imperfections while the power delivery remained smooth. Each acceleration was controlled, gradually increasing to ensure that repaired components held firm. The team listened carefully, watching for any unusual sounds, scanning diagnostic data, and confirming temperatures across the cooling system. Confidence built slowly, because reliability is not proven in seconds but in consistency. As the pace increased, the machine began to reveal its true character again. The enormous W16 engine pushed the car forward with effortless force, yet everything remained stable, a sign that alignment, mounts, and drivetrain repairs had succeeded. What once seemed like a fragile reconstruction now felt solid and composed. The steering tracked straight, braking remained balanced, and the chassis responded exactly as expected. This was a moment where theory transformed into proof, where months of effort converged into a single experience. The hypercar was alive again. Reflection followed naturally. The rebuild was never just about restoring a damaged vehicle. It was about challenging assumptions surrounding exclusivity. Statements suggesting that only specialized facilities could perform such work had fueled the determination behind the project. By completing the repair independently, the narrative shifted. It demonstrated that knowledge, patience, and dedication could rival institutional advantage. The once separated halves, the broken mounts, and the scattered components had all become part of a larger story, one about persistence and curiosity. As the drive concluded and the car returned to the workshop, the atmosphere felt different. The rebuilt hypercar stood not as a wounded project, but as a completed statement. Its engine ticking softly as it cooled, it represented the culmination of countless decisions, risks, and careful adjustments. And in that quiet aftermath, the message resonated clearly. The impossible is often defined by perception, not reality, and when determination meets engineering, even the most complex machines can be brought back from the brink.